Today's video is Chapter 7, Lesson 3. We're going to talk about scientific notation. Notice that in all of these, there is one digit, then the decimal. Then you could have one digit, two digits, three digits, no digits. Then there's a time sign, and then there's a 10. Sometimes the 10s have positive exponents. Sometimes the 10s have negative exponents. If you have a positive, you're going to go to the right. So the decimal will hop right 4 places. If it's a negative, your decimal will hop left 3 places. So in this first one, 4 hops to the right. 1, 2, 3, 4. That means I need 3 0 placeholders, 64,000. In the next one, I'm going to go left 3 places. 1 hop, 2 hops, 3 hops. I need 2 0 placeholders, and then the 291. I'm going to go 6 hops to the right. The decimal is after the 3. 1, 2, 3, 4, 5, 6. So the answer is 3 million. 5 hops to the left. 1, 2, 3, 4, 5. I'm going to do 4 0 placeholders, and then my 701. If you look at it, you can say if I'm doing 4 hops and I have 1 digit, then I'm going to have 3 placeholders. The negatives will always have to go 1 hop just to get in front. So the number of zeros will always be 2, will be 1 smaller than this guy. 6 hops, there were no placeholders, so it's 6 zeros. 5 hops left, 4 zeros, because it always takes 1 hop just to get to the front. If I have an 8 and I have 3, how many zeros will I have? I'll have 5 zeros. 1, 2, 3, 4, 5, and then the 3, the 2, the 1, and the 3. 312,300,000. This guy is going to hop left 1, ends up with 0.99. The first question of the video is to tell me the answer to this math problem. Okay, did you add 5 zeros in between the decimal and the 7? 6 hops to the left, 1 hop just to get in front, and 5 more hops. Now let's do the opposite of what we were just doing. I'm going to give you the final answer, and I want you to put it back into scientific notation. So I said before, there's always going to be a times 10. There can only be 1 digit before the decimal, so 7.2. Let's go times 10. There can only be 1 number before the dot, 6.423. There's always going to be a times 10 and only 1 digit before the decimal. There's always going to be a times 10 and there can only be 1 number before the dot. Always a times 10, 1 number in front of the dot. Always a times 10, 1 number in front of the dot. We know that these guys are going to have negative exponents, and the top ones will have positive. If the decimal was between the 7 and the 2, how many hops would it take to get to the back? 1, 2, 3, 4, 5, 6, 7. So my exponent is a positive 7. If my decimal was between the 6 and the 4, 1, 2, 3, 4, 5, 6. Between the 7 and the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If my decimal was between the 1 and the 2, 1, 2, 3, 4, 5, negative 5. Between the, it would come after the 8. 1, 2, 3, 4, so it's a negative 4. Between the 1 and the 2, 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. All right, you try typing in the answer to this one, and you won't be able to type in an exponent. So what a lot of times math people will do is they'll write 10, and then there's a caret button. I think it's above like the 7 or the 8 key. And then you can type in your exponent and that means 10 to the second power or 10 to the fourth power. So you can type it in like that. Did you type in 6.05 times 10 to the 8th? We can only have one number in front of the dot, so that's our 6. If the dot's after the 6, between the 6 and the 0, it takes 8 hops to get to the back. It's positive because we went larger, we went to the right. Something we can do with scientific notation numbers is multiply them. So in this case, I have 2 in front and a 4 in front. I get to multiply those guys to make an 8. My exponents fall back to that rule. When you're multiplying, you get to add. So the answer is 8 times 10 to the 13th. But what happens when these first numbers become 2 digits? We can't have 42 times 10 to the 9th because scientific notation can only have 1. So I need to make it 1 smaller, 4.2, which means I have to adjust the 9 and make it 1 larger. Let's do another one. 3 times 9 is 27. 21 plus 5 is 26. Oh no, it's 2 digits. I have to adjust and make it 1 place smaller. So I adjust my exponent and make it 1 number larger. What about when we have negative exponents? 6 times 4 is 24. I still add the exponents. Negative 4 plus negative 8 makes a negative 12. Oh no, I've got to adjust because it's 2 digits. So I go 1 number smaller, 1 place value smaller. I have to go 1 place value larger. However, if you think about this on a number line, is negative 11 or negative 13 going to be larger than negative 12? Negative 11 is 1 larger. It's closer to 0. For this next example, I decided to have decimals in the front of the times 10, and one of them is positive and one is negative. So let's do the 6.5 times 8.7 stuff first. I ended up with 56.55 times 10 to the what? Well, I've got a 12 plus a negative 5. That makes 7. Oh no, this isn't correct. I can't have 2 digits before the dot. So I adjust it down to 5.655. Since I went down 1 spot, I go up 1 spot. All right, let's take this scientific notation. This whole thing is squared. So you could think of it 2 different ways. You could say this 2 affects the 8 and the 2 affects the negative 4. 8 squared is 64. 10 to the negative 4th times 2 is 10 to the negative 8th. I've got to adjust, so I make it 6.4, and I go up by 1, which is actually negative 7. But I said there's 2 ways of looking at it. You could write it out twice. 8 times 10 to the negative 4th, and 8 times 10 to the negative 4th, and now it looks like these questions. This is fine if the exponent is a tiny 2. It's okay to do this. But if this exponent was much larger, you would want to do this option. Here's your last question of the video. Type in your correct answer after you've multiplied and adjusted. Here's the correct answer. I multiplied. I didn't have to do any adjusting. 8 plus 22 is 30.